Okay, in this first lesson for vectors, we will go through what is a vector, what is a column vector versus a position vector, how to find a magnitude of vector, and we will explore this relationship between PQ, okay, and the position vector of Q, position vector of P. Alright, now let's begin. What is a vector? Now let's say you have a rectangle here. Okay, this is a rectangle. And then let's say this is 10 cm length and the breadth is, let's say, 4 cm. Now these quantities here is what we call a scalar quantity because it only has magnitude. Magnitude means the 10 cm and the 4 cm here, it only has this value and no direction. Alright, like the direction is not important. Okay, what do I mean? Okay, I give you another example. Let's say I have a ball here, right? Then I use a force of 2 newtons, for example, a force of 2 newtons, and I push it this way in this direction. Then this is called a vector. This force here is called a vector. Why? Because it has magnitude. Magnitude means the 2 newtons. 2 newtons here, right? Okay. And also, it has direction. That means this force has a direction. That means if I push it this way, the ball will go this way up, right? But if I were to push it the other way, 2 newtons, then the ball will go the other way. So the direction is important for this case of force, whereas the direction here is not important. This one only has magnitude. Okay, so a vector is something that has both magnitude and direction. Okay, so what other quantities have direction? Now for those of you who study pure physics, you will know velocity, which is something like speed, but it has direction. So if I have a car here, and then the car is going this way, the velocity is, let's say, 2 meters per second. Okay, if the car now changes direction and it is going the other way, then its velocity would have a negative here to tell us that it is going in the opposite direction. So velocity also is a vector. Okay, a vector quantity. Force is also a vector. Okay, but you don't need to know this. You don't need to know this because you will learn this in your sciences. What you need to know in mathematics is that a vector, right, has both a magnitude, that means a value, and it has direction, that means the direction is important. Alright, now let's go to the next thing, which is getting you used to vectors, how to deal with vectors. Now let's say this direction, let's say I have a vector in this direction, okay, it's a straight line, okay, and then I call this vector A. Alright, and if this point is, let's say, P, this point is, let's say, Q, then PQ, okay, to denote this PQ, right, I put an arrow on top. Okay, the starting point P and the ending point Q, right, I will write here, start from P, end at Q. Alright, and I draw this arrow to the right to tell us that it's going from P to Q. P to Q. Alright, and this vector PQ is by definition, don't have to memorize all this, okay? It can be A lah, B lah, Z lah, whatever. I'm just giving you an example, okay? The question will give you all these points, all these letters, okay, it will be A. Alright, and in order to denote vectors, you must put a curly uh, symbol under this small letter. Okay, so I repeat, if I have another vector, right, going from here to here, then let's say this is point A, this is point B, right? To go from point A to point B, this vector, I need to put this arrow to tell people that it's a vector. Okay, the value will be, they will give you, let's say it's P plus Q. Okay, that's not the way to write it. You must have curly, this curly thing, curly symbol at the bottom. Yeah, so that's it. Okay, now I give you more example. Now let's say I have, using this as an example, right? If now I have another line parallel to this vector A, and in the same direction as this vector A, that means same length, same direction, parallel, this vector will also be A. Okay, but all right, this point is not P and this point is not Q. Okay, because point P and Q, they are fixed here. All right, but this vector, okay, we will call it A. That means anywhere I can draw anywhere in this direction parallel to this original PQ, right? And then if it's going in this direction, this will be A also. Okay, so that's the whole idea about vector. Same direction, same length, the vector is the same. But of course, you cannot say that this is point P, this is point Q, because point P is here, point Q is here. It's like a coordinate geometry. The point here, P and Q, they are fixed here. They cannot go. But the way we denote this vector A, right? Okay, in this direction, with this value, okay, is vector A. Okay, now the next thing I want to go through is this. Okay, I give you more example. This P plus Q, if I have another line here parallel to this same length as this, right, then this will also be P plus Q. Okay, and now if I have a line again parallel to this original, and this to this also, okay, but in the opposite direction, then this will not be A anymore, but it will be minus A. This minus tells us that it's in the opposite direction, exactly same length but in the opposite direction. So all these are minus A. Okay, you must put the curly braces here. Sorry, I forgot to put this just now. Okay, so all these are minus A. Alright, now what if I have a line parallel to this but in the opposite direction, same length, okay, but in the opposite direction? Then I have to change this to minus P, minus Q. Alright, I will give you one last example so that things are very clear. If I define this as P, vector P minus vector Q, then what is this, which is of the same length but in the opposite direction? It must be different sign from this, different sign from this. Okay, so I've introduced to you what the negative means. It means opposite direction from the original okay, so that is all for this part here. Now I'm going to move on to something else. Now let's say now I call this point A, this point B, okay, and then this point C. Alright, and then if you're given by the question that to go from A to B, this is vector P, okay, small p, this is small p, then I put a curly symbol here. Then in this direction from A to C, it is Q, okay. Then if now I want to ask you, right, how to find the vector BC? What is BC equals to? Okay, so that's something new. Okay, to do this question, you first of all think of it this way lah. It's like you're at Bedok, right? Bedok, then you go Changi. To go from Bedok to Changi, there's no direct bus. Okay, this red color line, you don't know the value, right? That's what they want you to find, right? Okay, you don't know the value. That means there's no direct bus lah. Alright, okay, so how do I do it? I maybe take a bus to somewhere, let's say Ang Mo Kio, then from Ang Mo Kio take another bus to here. Okay, so you're going to go this way, but because you are going in the opposite direction of P, so it's minus P. Alright, then from A you go this way. Now when actually all these lines are, these red lines are straight one, I just want to overlap. Okay, so now I when I go here, am I going the same direction as this original one? Yes. When it's the same direction, right, it's you follow the sign. When it's the opposite direction from the original, okay, you change the sign. You see, from plus I become minus. Alright, then must remember put the curly symbol. Alright, so that is the whole idea of vectors. Very simple. Okay, now I give you another example. Let's say I want to go from now, I want to go from C. Oops. I want to go from C to B. Okay, so you draw your arrow. C to B. No direct bus, right? You don't know what this is. Okay, so I will go this way, which is minus Q. So CB, you go from C to B, right, is minus Q. Okay, then you go this way, right, plus P. Okay, so you can say P minus Q also can, or you can write this way also can, not a problem. Okay, so that is the whole idea. Alright, now let's say now I want to check whether all these are correct. I want to check whether all these are correct. Okay, so now if I check CA, sorry, not CA, okay, AC, AC. We know that to go from A to C, the answer should be Q, right? That is what's given by the question. So I'm trying to prove to you that what I've written here are correct. Okay, so to go from A to C, the answer, my final answer should be Q, right? Okay, let's see. Using the method that I taught you, right? To go from A to C, I got to travel this way and then this way, right? Okay, so what is this way? It is P. Correct? And what is this way? Okay, just now CB, we say that it's minus Q plus P. Correct? Okay, so I'm going in the opposite direction. I'm going this way, right? Whereas the original direction CB is minus Q plus P. So I must change this sign. Change this sign. Isn't the answer Q? Yeah, so I've proven to you that this one is correct already. Okay, now I'm going to prove to you that even if I were to use this, my answer also is correct. Okay, so this is BC, right? Okay, BC means I go from B to C. And what is the vector? Minus P plus Q, correct? Okay, so I label here minus P plus Q, and it must be in this direction. Remember, when you do vectors, right, you must label both the magnitude and the direction. Okay, you see I label the direction, very important. Okay, now I want to find AC, right? And we agree that AC, the answer should be Q, right? So just now I used this and I proved to you that this CB is correct. Now I'm going to prove to you BC is correct. Okay, to go from A to C, I must go AB, right? AB is P, don't you agree? Then after I reach B, I must go from B to C, and that is same direction, right? Same direction, I follow exactly what is there. So it is minus P plus Q. Okay, now don't you see that we end up with Q again? So even this that I've shown you is correct. Okay, so I've proven to you already. Now this is a very important relationship, and this is a very important technique. Okay, remember when you go in the same direction, you see same direction, you follow the sign. Same direction, you follow the sign. Different direction, then you change the sign. Each of the sign you change. Okay, so that is the end of this section. Now I go to the next section, which is, now all this while I've been talking in like in space. What do I mean by in space? That means there's no background. You see the white background, the background is white color, right? Nothing, right? Okay, now I'm going to bring in the coordinate scale. Coordinate scale means this one now, meaning the x and y axis. Okay, now let's say we now talk about vectors in the coordinate scale. Okay, there'll be questions like this, so you must know how to do. Now again, let's say I have okay, let's say I have a vector like that. Okay, and it's going in this direction, and let's call this point A, let's call this point B. Okay, now if I have a vector in this direction in the coordinate scale, that means got x and y axis one, so you will find that these vectors, right, is related to this topic called coordinate geometry, and they can, in the O level, they can combine these two topics together to test you one question. Okay, so that's what I'm trying to train you here. Now if I put this in the coordinate axis scale, then it will not be P, Q, all that already. Okay, you will need to use your x and y to define this vector. So it's actually very simple. To go from A to B, vector, right? Vector, so I must put an arrow here, and this must be capital. Okay, it is actually like your coordinate geometry x, y. Okay, how do I go from A to B? I will move 1, 2, 3. You must see here carefully. 1, 2, 3. Each box is 1 unit. So this is 3 units, and then you go up, right? Up here. So you write 3 and then go up. You see, although 2 boxes, it's only 1 unit. 3, 1. So that's how you do it. Okay, so I repeat, when a vector is in a white background, right, they most of the time will tell you, oh, this is P plus Q or whatever, A minus B or whatever. Okay, but when it is in the coordinate scale, they will not give you P plus Q or whatever. You yourself have to know that it is X then Y. So this first value, okay, this first value right here is your X. The second value is your Y. Alright, so this is what we call a column vector. Remember just now I told you that I'm going to go through column vector versus position vector. Position vector I'll go through later. You will learn column vector, the general case first. Okay, now I think all of you should agree with this. Okay, now what if I want to go B to A? I want to go from here to here, so it's no longer this direction but this direction. Then it will be, again, always start with the X. I move 1, 2, 1, 2, 3, minus 3, right? Minus 3 units, and then I move down. That means your X must always come first. So it is minus 3, then minus 1, minus 1. So don't you agree that the thing that we learned just now applies if I go in the opposite direction, then I change the sign of this, I change the sign of this. It's the same for this, you know. Okay, can you see that to get from here to here, A, B, you want to find B, A, right? You change this sign, change this sign. Okay, so let me just give you an example. Let's say I have PQ, right? PQ, if I tell you is -1, 4. Then what is QP equals to? It's the opposite direction, right? So you change this sign, and that's your answer. Finish. Okay, so that is how you do how you do this question lah. Okay, okay, so that's all for this particular part. I'm now going to go through another example. Okay, let's say now, right? Same thing. A and B, same thing. A here, B here. Okay, now we are going to introduce something new already, and this something new is called position vector. Okay, position vector. Now, do you agree that this point A, if I write it in the coordinate geometry form, okay, what's the coordinate? 1, 2, right? Okay, 1, 2. But if I want to write it as a vector, okay, then we have to start from 0. This origin here, okay? Origin, we always define it as O. This origin here, right? 0, 0, we define it as the point O. So to go from O to A, O to A, don't you agree that you have to move 1 unit in the x-axis, positive 1, and then 1, 2 in the y direction? So this is how you write the coordinates of a point, and this is how you write the position vector of A. This OA, right, is what we call the position vector of A. So what is the difference? I come back to my original, this main thing that I want to teach you. What's the main difference between column vector and position vector? Position vector, the starting point must be point O, and actually it will give you the coordinates. This position vector, right, is actually linked to the coordinates of the point. Okay, now can you try now to give me the, okay, we do the coordinates of B first. Don't you agree it's 4, 3? And if I want the position vector of B, I must start from O, go to B, right? So OB, you must put arrow, is equals to, you must write as a column vector. That means you cannot write sideways like that. You write 4, 3. Okay, so this is the position vector of B. Alright, now this is point A, this is point B. Now I'm going to go through the last, is it the last thing? Wait, let me see what I wrote there. I have gone through this one, right? What is a vector? Vector is something with magnitude and direction. That's all. Nothing very much. You just need to remember to label capital letter, you put the arrow on top. Small letter, you put the curly thing at the bottom. Okay? So it is to tell people that there is direction. And then for on your diagram, you must put the arrow either like that or like that, depending on which direction. Okay, position vector, column vector. This is your, on the coordinate axis, this is your x, this is your y. This is your x, this is your y. Okay, only on the coordinate scale, you must have x here first and y. X here first and y. Okay, so what's the difference between position vector and the column vector? The position vector can actually give you the coordinates of the point. Okay, whereas column vector, this position vector also is a column vector. Okay, let me go back. But this column vector, right, it can be between any two points. Then this is a column vector, for example, like that, right? How to go from here to here? You 1, 2, 3. 3, 1, 2, 3, right? Then you minus 1, 3 minus 1. So this is what we call a column vector. Okay, but position vector is different. This position vector, okay, let's say this is C, this is point D, right? Okay, never mind, that one will be confusing if I draw here. Okay, I thought about this. Okay, position vector, this OB would be what we call a position vector because it starts from O. So a position vector starts from O. Column vector is any of this column vector, need not start from O. Okay, yeah, so that's all lah. Okay, so these are the two things that I want you to know. I've done this already. Okay, yeah. So now I'm going to go through the next thing. Magnitude and also this relationship. Then we will end this lesson. Okay. Okay, now let me use OB as an example. If now I want you to find how long this OB is, what is the answer? Now, how old this vector OB is, we actually have a short form to represent it. You know, maths, we always have short form, right? Now, the length of this vector OB, okay, can be represented by just drawing these two straight lines here. These two straight lines is telling us the magnitude of OB or the length of OB. Okay, and looking at this diagram here, don't you agree you can use Pythagoras theorem? Because there's always a right angle that you can draw. Right angle. See, right angle. Anywhere also got right angle for any of these vector, right? Even here, you see, right angle. Okay, so to find the magnitude, very simple. Use Pythagoras theorem, which is 4 square. It's actually the hypotenuse. Can you see this OB is the hypotenuse? Then your answer is 5 units. Must write the units. That's it, finish. So to find the magnitude of a vector, right, it's just using Pythagoras. The magnitude is actually the length. Okay, so you just use Pythagoras theorem. Okay, so for example, like that, right? You want to find this magnitude of this vector A is always the hypotenuse that you're finding. So A, this vector is equals to, this is x, this is y. X square plus y square. Finish. Then get the answer in terms of units. Okay, so that's how you find magnitude or the length of a vector. You can think of magnitude as the length. Okay, so that's it. We're done 1, 2, 3. Now the last thing I will go through is this fella. Now PQ is equals to OQ minus OP. Now what is this trying to tell us? Okay, let me show you using some examples. Okay, what I'm trying to show you is this. PQ, okay, I can actually break up into this second position vector minus the first position vector. Okay, then you ask me, what am I talking about? Okay, I show you some examples. To go from A to B, right, I take the second position vector minus the first position vector. Okay, similarly for all these, is second one, right, minus the first one. Remember, when you go from O to any point, you go from O to any point, O to any point, all these are position vectors. Okay, so I can give you, I can write until tomorrow, A, B, C, D, whatever, all of the different combination, right? But it's just a second position vector minus the first position vector. Okay, let me explain to you why like that. Okay, so I will use this to explain to you. Let me erase all this, very confusing. Okay, so we just focus on this diagram, okay? If now I want to find A, B, right? How to find A, B? It is just the second position vector minus the first position vector. Okay? Similarly, if I want to find B, A, now B comes first, then A, right? So I always take the second one minus the first one. Okay, now this relationship is very important because later I'll show you this O-level question. You need to know this in order to solve the question. Why is it like that? I'm going to prove to you now, okay? To go from A to B, don't you agree it's like that? To go from A to B. So, A to B, just now we learned, right? To go from A to B, if I don't know this, then I'll travel this way. Oh, travel this way is minus OA, right? Minus OA. Correct or not? Then after I reach O, I come this way. Oh, same direction. Same direction, then it's just plus OB. That's why if I just write this in front, and then I write this at the back, I've proven to you that AB is the second one, then minus the first one, the position vector. Okay? I hope you are clear. Okay, I've proven to you already this one. I'm going to prove to you this one now. What if I want to go from B to A? Why is it the second one minus the first one? Okay, I show you now. It's the same reasoning. But you see, vectors very important. You must get the direction right. Now, just now I draw like that, right? Because I want to go from A to B. Now I want B to A. This way, right? I will go this way. Oh, opposite direction from OB. So it's minus OB. Okay? Then I go this way, right? Oh, same direction. Same direction. So it's OA. Plus. That's why it's OA minus OB. Okay? Alright. Okay. I can go on and prove to you a lot of things, but no point. Let's move on to the real O-level question. Okay, now let's try to get this right first. So you all agree with this? What about yx? xy is second one minus first one, right? Then yx, that is the second one, which is ox, then minus oy. You must know how to break it up like that. Okay, now let's go to the what is this called? O-level question. Okay, 2016, that is about 6 years ago. Okay, you are given that AB, vector AB. Okay, this line here, there's an arrow. Printing not so good. There's an arrow this way. Okay, it's always pointing to the right, the arrow. Okay, find, like that. These two lines here means what? Magnitude or the length. So the answer is simply Pythagoras theorem. Now you see the minus here, right? You must put bracket, okay? You cannot write, later I show you. You cannot write minus 8 square plus 15 square, then square root. Okay, this will be marked wrong. You must put bracket. Brackets are very, very, very important in mathematics, okay? Then you go and press your calculator. You will get the answer. Okay, let me press the calculator. Okay, square root. So it's 17. Alright, don't just write 17 because this is a length on the coordinate scale, so you must put 17 units. So that's for part A. Finish. Alright, now Part B, they say C is the point 420. Then DC is this. Find the coordinates of D. Wow, how to do this? Okay, so this requires you to know the relationship between like just now I say here, this point A is 1, 2, right? Then I say that, oh, it means that if I change it to a vector, it will be 1, 2, like that. Okay, you must know how to change from coordinate geometry to vector, vector to coordinate geometry, because as I mentioned just now, they can set this as one question, which is what we see here now. Okay, so do you agree that this is your OC? C is a coordinate. Okay, C, this 420 is the coordinates of C lah. So vector, position vector of C, which is OC, right, should be X first, then Y. So that's how you convert it into a vector. Okay, why must convert it to a vector? Because all this, there's an arrow here, is a vector. This is a vector. Okay, so now I'm going to play around with this. DC, that means to go from D to C, is the same as 2 times of going from A to B. That's what they're trying to tell you. Okay, then they want you to find the coordinates of D. Don't you agree that once we can, okay, coordinates of D means like that lah, so X and Y, right? But don't you agree that once we can find OD, which is like that, then we will be able to find these coordinates of D already. Okay, so we need to find this. How to find this? Break this up. How to break this up? We learned just now already. Spend so much time here talking about it, right? Spend so much time here talking about it. Break it up into its position vectors. Position vectors, okay? Why? Because position vectors are actually the coordinates. So you see, DC means the second one minus the first one. And then this fella, these two, leave it outside first. It's like algebra. Second one minus the first one. Okay? Then now, OC. Do we know OC? Yes, we know OC here. This is your 420, right? Do we know OD? We don't know. That's what we want to find. Then once we know OD, we will know this. Okay, then now this is your 2. What is AB? Do we know AB? Oh dear, I shouldn't be doing this. Why? Because AB is here. So don't do things blindly. Okay, so just now we don't need to break this up, but we need to break this up, right? We need to break this up because we want to find OD. So whether you need to break up or not depends on the question. Okay, now how do I multiply this? It's like your matrices. You know, we learn matrices. So this is this time this time this. So it's minus 16, 30. Alright, now how do we manipulate from here? You can leave this here. Okay, you don't want this, right? So you minus both sides, this one. So you minus 16, 30, right? You minus this from both sides, so it's minus 420. Okay, actually we are killing two birds with one stone. We are revising matrices now as well. Okay, this is minus OD. Don't forget the minus is still there. I haven't got rid of it. So how do I do this? It is minus 16 minus 4. So it's minus 20. Okay, then this is 30 minus 20, so it's 10. Alright, but this is minus OD. I don't want minus OD, I want OD, right? So it means that I continue here. OD, I multiply by minus both sides. This will change to 20. This will change to minus 10. Okay, don't leave your answer like that because they want coordinates. Is this coordinates? No, this is the position vector. It's a vector, position vector of D. But you can easily convert this into coordinates by writing them side by side, the X and the Y value. Okay, so this is your answer. Finish. Okay. Now I will not go through C because I haven't taught you C yet. Actually I have lah, but I need to teach you more then I can go through C. Don't worry, I'll go through in the subsequent lesson.